would say I would pass the word to Dr. Ayoola to start with this presentation.
Thank you very much, Christina. Do I just go ahead and present and share my screen?
Yes, please.
All right, thank you very much. All right, thank you. My name is Dr. Ayoola, as earlier introduced, and I am the founder and CEO of Robotics and Artificial Intelligence Nigeria. I'll be speaking about the educational side, also trying to introduce to us robotics and its role in the oil and gas sector, particularly enhancing process safety. So what is a robot? Because it's important we clarify that a robot is not just a humanoid device. It's basically an electromechanical device that has links and joints, or maybe wheels to move. May not even move in some cases, but can at least manipulate around the space. Guided by sensors, driven by actuators, which could be the motors that move it, or any other kind of powering system. And it's controlled by software run on a microcontroller. I understand that we have several types of microcontrollers, the Arduino board, the ESPs, the STMs, and co. But then, as long as one can program a board to control actuators, to listen to sensors, then that's a robot basically. The purpose basically is to handle and manipulate items in the vicinity of work and maybe perform some tasks. The kind of tasks that we get robots to perform are tasks that are repetitive, dangerous, impossible, delicate, or even supporting people with special needs. And special needs does not really relate to people with disabilities, but in cases where one is handling some tasks that require special support, that could be one with a special need. And when you look at the oil and gas sector, the energy sector in general, some tasks are repetitive to the extent that a human might get bored, might lose focus. In that case, we need robotic systems helping to monitor those things. Dangerous tasks, even though we try to achieve safety in all of our operations, when there is need to adopt some steps, when there is a dangerous, like a hazard, robots can take that risk for us, and so many others like that. Robotics on its own is the field of study that incorporates mechanical engineering, electrical engineering, and computer science towards building robots. And when we talk of robotics, it's not enough to learn mechanical, electrical, and whatever. You need to have understanding of the concepts you're trying to solve using robots. You must have knowledge of the design of robots within the workspace, because robots are designed not just for the sake of being a robot, but for the purpose of solving problems within an environment. So they must be designed within that, with the framework of that environment in mind. And also we make sure we have knowledge of manufacturing, because the method of manufacturing determines the durability of the robot, the acceptability and the standards of such robots, the manner of operations too. For example, in the oil and gas, you might need to be able to say, well, this robot can work while the system is in line, or you may have to make it offline, or in some cases shut down the entire system. So different robots would be based on such operational designs. There are categories of robots. The most common assumption is that robots are humanoids, looking like human beings, like the picture on the top. But then we have robot manipulators. These are just robot arms that can pick and drop and turn around. But then that's what they do basically for helping manufacturing, helping with clinical assessments, tests, and laboratory analysis. But we also have unmanned aerial vehicles that are very useful in the oil and gas and the energy sector for monitoring remote areas, particularly checking if our pipelines are safe, if there is no leakage, and if it is still intact. The case of unmanned ground vehicles will be useful in monitoring flow stations, oil wells, checking if the vicinity is safe, there are no spills, or there are no abnormal events occurring. Underwater robots are a lot more interesting when you think of the offshore, where you have rigs and there is need to inspect, and there's a need to inspect the corrosion or not corrosion underwater. I've been part of a project, that built a kind of robot that could clamp onto the rigs just to inspect around it to see if there has been any corrosion or need for welding. Underground robots, that's a bit far-fetched for now, but it's being used to monitor mines and mining operations. So common use cases of robots are welding, and I'm mentioning the ones in red because that's what applies to us in in this sector. Welding of pipelines, paintings. Paintings do not have to happen when we remove the pipeline from operation. It could still be in operation, and you have a robot spending day and night painting. Cleaning as well of tanks and other systems. More importantly, for security and safety, surveillance, we need robots for that. I've mentioned aerial vehicles and ground vehicles, and of course underwater. There are some requirements that robots must have, and one of that is localization and mapping. When you build a robot, whether it's a drone or a ground robot or one that washes the tank, it must be able to know where it is within that system and report precise location, especially if you are using it for calibration, for mapping of the tank and inspection. There is need for localization and mapping. So we call that SLAM in robotics. And the knowledge of it is very important, so that if there is need to recalibrate, one can, of course, understand the way it works. Adequate situation awareness. You have any robot in any space, it must understand the situation awareness. It must have situation awareness. You must know when there is a fluid, what kind of fluid. So sensors are used for this. In some cases, we use LiDAR to detect obstacles around the robot so that it doesn't create any catastrophe. Calibration is key, and I'm just going to quickly move through the slides because of the time I've been given. Communication, most times we try to achieve remote communication, but you will agree with me that when we are monitoring remote facilities, there's usually that challenge with real-time internet access. So most times it's either we use GSM or we use onboard storage devices to keep all of the data on board the robot till it gets back to the ground station. In a case where you are deploying this robot within a facility, most times we resort to wired tethered communication so as to have complete assurance of data transfer. Sufficient power supply through DC or batteries. I mean, that's usually the case, but most times the amount of time a robot must spend working determines whether battery power will be sufficient or it has to be tethered to a particular power supply. And in fact, in some cases, batteries are not safe unless we do enough quality assurance. There's a project where, when I was working in the UK, we deployed a camera system into an oil well. So we had to make sure we pressure tested every part of this camera to be sure that under no circumstance will it spill open and expose the batteries. Safe access and retrieval in case of failure. It's not enough to deploy a robot. You must have the plan of how to retrieve it if the robot fails to be able to crawl out itself. Facts about robots that we often misconstrue. The work environment must be designed to suit the robot deployment. So it's not enough to say, oh, can we start using robots? Was the deployment of a robot in mind when that facility was designed? If not, we need to start rethinking the design of our facility. For robots to move around, for drones to fly around. Adoption of robotics must be in the design. I've just said that. So accuracy and precision of robots depends hugely on our calibration and our system adaptability. What this means is that even if a robot has been designed abroad, someone must calibrate it for our own local environment. It's not enough for us to say it worked in the UK, it worked in Canada, so it should work here. Our local expert must also do some calibration to be sure that the readings are exactly as it should. I've worked with some underwater robots that need to tell you the location of a robot vehicle underwater. But we figured out from my research that it's also dependent on the quality of the water itself, the turbidity of the water, because if you're using acoustic signals to detect or predict your distance from a particular object, you need to be sure of the turbidity, the salinity, and of course the presence of clutter in the water or not. Now, if we are going to encourage the adoption of robotics, certain things must be taught in class or in retraining programs to our workforce. SLAM, which I told you, is about making sure we know where the robot is and mapping the room where the robot is. Motion planning and navigation. Now, that's a very, very big challenge. In most cases, robots are operated by remote drivers. So we call them remote operated vehicles. And the reason simply is that most systems are not developed enough to the point where they can plan their own motion and control their own navigation themselves. Well, for me, that's one of the things we've been doing. Building robots that don't need humans to man them, but just to observe what they're doing. Robot Operating System, ROS, is a critical infrastructure now when it comes to managing several robots within the same space. They need to communicate together. So ROS is a platform where robots share knowledge and updates. Computer vision if we are going to be using robots to decide, then they should be able to inspect and decipher what they are seeing in terms of objects and any other kind of analytics. So that's important. IoT, Internet of Things, very critical for monitoring remote events using Wi-Fi enabled systems or GSM enabled systems, and the rest are all there for us. Number 7 is most important for me when it comes to safety. I believe that in the oil and gas sector, we've done enough when it comes to making sure every process is secured, is approved, has its own tagging in and tagging out. But then there is need to make sure AI does some of these things for us. For example, if anybody mistakenly or forgets to tag in when going into an oil field or an oil tank, AI should know based on other events that have happened, other procedures that have taken place, that wait, even though this has not been tagged in or tagged out, there is need to automatically help that person or send some alert. So AI running in the background of any robotic system is critical for safety. The gap that RAIN fills is that we provide some sort of training beyond what the universities in Nigeria would provide, and that's practical exposure. With our laboratory in Nigeria here, we're able to provide this kind of top-notch training, and also supporting industries with, solutions that are bespoke. I should have mentioned that when it comes to robotics, you don't just buy off the shelf. It has to be tailored for your field, for your industry. And in some cases, the industry keeps developing new ideas of how robotics can support them. And what we do, we are at the forefront of building such solutions that they can then commercialize. One of the things we are doing when it comes to solving problems is the use of drones.
Recording in progress.
Is the use of drones for detecting terrorists. And I'm talking about militants in the region that are trying to disturb the pipelines. And by using drones fitted with cameras and optical cameras and carbon emission trackers, we can detect their presence and detect if there has been any situational changes. In particular, what that project was doing was checking if anything has changed from what was seen yesterday to what was seen today. We've also been building underground, unmanned ground vehicles and so many other solutions for different sectors, including the healthcare sector. RAIN has been involved in some government projects, supporting in organizations and building partnerships locally and internationally. So what this means is that RAIN is positioned, to become part of the solutions we need in Nigeria. Because I personally returned to Nigeria in 2019 after some exposure, some work with the UK's Nuclear Decommissioning Authority, because I wanted to make sure that we bring this technology home where we can have indigenous experts. And we've been doing that, training a number of people. The only problem is that you train people, they leave the country because there are more opportunities outside the country than here. The only time opportunities will improve here is when industry key players like you begin to see that, well, why can't we invite these local champions to come and set up some robotics facility in our oil and gas facility? At least the automobile industry are doing that. You have Toyota building a robotics laboratory. Why can't we have the same thing with the oil and gas sector? We need to tackle insecurity, pipeline vandalizations, and so many other infrastructure attacks that we have in this country. Finally, I'll end with this one. We are building an optical system mounted on a drone, optical camera, that can detect, using AI, events that are happening on the ground and alert the authorities. And that's just one of the solutions we have under our sleeves. So in a nutshell, locally, we can build solutions, but then it's now up to the industry key players to give the platform for testing and adopting. Thank you very much, and I will leave you with the next presenters now.
This is great, thank you. This is a very inspiring presentation, and it's fantastic to see that you're setting the grounds for that change to happen in Nigeria for generations to come. So definitely an advice for the industry to keep working on robotics and bring it home. So let's pass on Edwin presentation. Edwin Moses will delve into the critical role of robotics and automation in advancing process safety. So the floor is yours. Thank you.
And that is Ayoola reporting for NTA News.